All right, good morning, good afternoon, and good evening, everyone on the line, and also for the people to review the recording later. Welcome to today's EiB Gobi webinar. Today, we are honored to have Mariano Crimi from EiB team to give us an update and also live demo on the new features and progress towards an API-driven development. My name is Star Gao. I'm at GOBii Kernel Ithaca. We in the room, I have our director, Dr. Liz Jones, lead developer Yao, and also our meat breeder Carlos visiting from Erik. Also Ian and Gordon visiting from JHI Scotland for the week. So we are sitting in the room. And for everyone on the line, our speaker, Mariano, he joined IBP team since 2016, and he's the BMS product manager. He leading a team of 8 developers and 3 quality assurance specialists. Mariano has the background in software engineering and have been involved in complex software development projects in a wide range of industries for more than 10 years. So really honored for the IBP team to give us an update since I think maybe about a couple years ago, we had a demo and also had a breeding management system review across several CG centers. So Mariano, is young Erik also with you today?
I think so. Okay. Yes.
Yeah. So I would like to introduce and start the presentation. If you want to introduce young Erik, or he will just help with QA session. So go ahead, Mariano, to take the floor. Thank you very much.
All right. Well, thank you, Star, for the space. I'll just go ahead and introduce Erik Backlund, which is the IBP development director. I think he's gonna make some remarks or help me answer some of the questions that you might have at the end of the presentation. But yeah, so I guess I'll just start. So as you said, Star, the idea would be to cover some of the new features that we've been developing in the BMS for the last 1.5 to 2 years, and the progress towards an API-driven architecture. So let me start by telling you about. Can you guys, see my screen and hear me okay?
Yes, we can see very well. Thank you.
Oh, okay, fantastic. So version 13 has been recently released last month, and I had the pleasure to see it in action, being used by breeders and data managers in real life. That was kind of a privilege. So I've spent last 3 weeks in Ethiopia working with the Ethiopian Institute of Agricultural Research and the University of Queensland in basically training people in the BMS usage and workflows, and exposing them to the latest features of version 13. IBP has partnered up with the University of Queensland under the umbrella of a project called Mercy, which is funded by the Gates Foundation, which aims to modernize breeding activities for this particular institute. And we are mandated to provide the BMS and the support and training. So took the opportunity to go there and talk to the users and see them in action with the latest version, which can be quite scary because it's, you know, it's brand new, fresh from the oven, and you have like 30 people in the room playing with it. And so it's both terrifying and illuminating. Yeah, great experience. And as I said, put to the test the latest features that we've developed, in particular, the one that I want to discuss today, which is the new observations module that we have enabled in the BMS, and which has been built, you know, in an entirely API-driven architecture. But before moving into describing the module and the strategy that we've taken to build it, and showing you what are the features there, I just want to step back a little bit and tell you about a decision that we've made as a team, I'd say 2 years ago or something like that. Where, you know, we had a strategy meeting in Teotihuacan, and we basically, you know, amongst other things, we decided to, you know, from the development perspective, we decided to move into a vision of, you know, depth over breadth in terms of, you know, the scope of the tools that we were developing and the way that we were delivering the software. So basically, in terms of delivery, we decided to focus only on you know, server deployments, both in the cloud or on premises, and we basically deprecated and discontinued the desktop version of the BMS that we had been releasing up to that point. In terms of you know, the scope of the tools that we were developing, we decided to divest from modules that had nothing to do with what we considered our bread and butter, the area where we were strongest, which is basically the germplasm management and the study management. So in this graph, you will see here some areas of the whole ideal breeding ecosystem where we divested and you know, decided to focus more on nursery trial creation and germplasm management, including the seed inventory, which we consider an essential part of the germplasm management itself. But of course, we realized that, you know, that's not it, right? You need more tools to accompany those very two core activities, and we decided that we would leverage other solutions, and in order to do that, we would transform these two core modules of the BMS into an API-enabled architecture that would facilitate connectivity with other modules. But we had, of course, some challenges in doing so, and I'll use here some construction metaphors. Please bear with me. But basically, you know, the BMS is, I mean, since we released version 4 2.5 years ago, or 3 even, you know, BMS has been adopted. It's a production software, and because of that, it's subject to, you know, features request, new enhancements, bug fixing, all of those things that are required for a productive application to keep serving the user base. On the other hand, we had inherited you know, an architecture that was initially conceived to serve, you know, single users standing on a desktop computer. So, you know, following this construction allegories, we had to keep serving users by building upper floors of the building while working on the foundations of the building. I mean, users, you know, and rightly so, they don't care about foundations. They want new roofs and new, you know, pools and, you know, things that are adding value to their workflow. So we had to combine those two activities in a way that we could, you know, work on the foundations and also on the upper floors. And so, I mean, this is a very common problem in software engineering. It just requires creativity and imagination. And I think that's, you know, the strategy that we followed to achieve these two seemingly mutually exclusive objectives. It's a proof of such creativity. So one of the main upper floors or new features that our user base required for quite a long time was the ability to handle sub-observations, to basically divide a plot into subplots or plans or quadrats or whatever, and take measurements on that level. And so while tackling that problem, we had a strategy that enabled us to, you know, build that and also replace some parts of the foundations of the common plot observations module that we had in the system. So the first thing that we did, so I mean, before version 10, we had two separate modules to manage nurseries and trials, and we had quite a bit of duplication in terms of functionality and code. So the first thing that we did is just to merge those two modules into a single managed studies module that would handle both types of studies. That took a while. It wasn't easy to do. We had to generalize some concepts, adapt some others. But at the end of the day, it simplified, you know, the context in which we were working. I think we had reduced the code that we had to change by something like 40% or 45%. So a considerable reduction in the study management itself in terms of, you know, the amount of changes that the amount of code that had to be changed. So once we had a unified study manager, what we did is we branched out, and so we started working on the sub-observations module in a completely separate architecture, in an API-driven architecture. So the first thing that we developed for sub-observations were the API contracts. Then we built the front end on top, but it was completely separated from the common plot observations module. So we had, you know, two modules living together, one with the old stack and one with the new stack. So by the way, so the unified managed studies, we delivered it in version 10, and so in version 11 we worked on the sub-observations basics, and we delivered that. And then we started adding some more functionality to the sub-observations module, you know, in the way that you can manage your outliers and filter your data. But more importantly, we realized that if we were envisioning that, you know, BMS would be connecting with different data capture applications, we would have to have a way in order to, you know, stage the receiving the incoming data in a place where the users might need to you know, curate or review the incoming data before committing it to a database. So that's something that we also worked in the sub-observations module. Just while the plot observations module stayed the same, right? So we did all of these things just in the sub-observations module. So we delivered that in version 12. So by version 12, we had a very complete sub-observations module in a brand new stack, but an old plot observations module in the system. So the trick is that we basically design the sub-observations module in a way that would be general enough so that it can take over the plot observations as well. So just with a hierarchical notion, we were able to, after some adaptations and improvements, we were able to fully replace the plot observations module with a brand new observations and sub-observations module. So in that way, we use this roof, this upper floor that we were building to replace part of the foundations of the system. And once we did that, of course, we had to take care of the performance, and so we went through a process of performance optimization. So in that way, we were able to deliver value. Every iteration we were able to deliver value to the users and use some of the pieces that we were building. We were able to utilize them to replace some of the foundations. So that's kind of the strategy that we took to try and achieve these two objectives. With that, I think I'll just proceed to the demo. All right, so I have BMS here. So I'll create a new study. Webinar demo. It's going to be a nursery. I'm going to select my entry list. All right, so I have my entry list. I'm going to just use one environment, save, and that will give me more options to continue. In terms of experimental design, we just choose no randomization for now. And that should give me my observations. This is a new module that I was just discussing. So what I will try to do in the demo is I'll try to capture data on the sub-observation level and bring it to the plot observation level using aggregation functions. So for that, I'll just add this variable that I have in the ontology, which has a formula, plant height centimeters. It's basically an average of itself. This is the function. And this is entirely configurable through the ontology, so you can go and create your own. And so I'll add this variable at the plot level. There we go. And now I'll proceed to create my sub-observations level. So observation unit options, create sub-observation units, and I get this message asking me how do I want to subdivide my observations into plants, quadrats, time series, or custom. I'll just choose plants. So custom basically uses you can configure a variable in the ontology that you would use to enumerate your custom sub-observation units. In the case of plants, quadrats, and time series, there is a variable already created for the enumeration. And so I'll create plants, and so I have to name the plants dataset. And I have to specify how many sub-observations do I want, or how many plants do I want to create per plot in this case. So I'll create 3. The enumeration variable is plant number. And given that I have only one instance in my study, there's just one instance to select. So save. And my sub-observation dataset is now created. So you can see here, I have for plot 1, 3 plants, plot 2, 3 plants, and so on. And this is the filtering that I was telling you about. I mean, this is also brand new. You can basically filter by any of the headers in the table. All right, so now I said that I wanted to capture some data at the plant level. So I'm gonna add the same variable that I have in the plot level, but at the plant level. So this is my variable, I think. And there we go. Now I'm gonna export study books here. Given that I have 2 data sets, I'm getting an option now to select which data set do I want to export, the plot observations or the sub-observations. I'm going to select the sub-observations because I'm going to capture data at the plant level. I'll save here. And I have prepared some observations with some values that I know that are out of bounds. So if we look at the variable definition, we can see that it's expecting values from 0 to 200 in terms of plant height. And so I deliberately added some values that are out of that range. So I save that, and I'm going to import the observations. I'm going to select plants because I'm importing plants. Excel, open, import. All right, so this is the first very important change that we implemented. We now have this accepted and pending switch, in which basically subdivides the data on data that has not been has been imported but has not been reviewed versus the data that has been already deliberately accepted. So if we go to accepted view, I see nothing. I haven't accepted any data point. In the pending view, I have all my data points pending validation. So I see, in red, some of the values that are not within the expected range. So if we go to filter out of bounds, I can see them explicitly, and I can take some action. So I can either correct them individually, so accept them or change them individually, or I can take some batch actions, which basically means applying the same action to the current filter that has been applied to the table. So in this case, what I'll do is I'll just change all of these values to the limit of the range. So plant height in centimeters, and apply new value to observations. And now just put 200, which is the limit. It's going to update 4 observations in one environment. Proceed. And there we go. And this is all in the pending view. I haven't accepted anything yet, right? So in the pending view, I'm able to do some of this curation and exploration of the incoming data. Especially important when you're working with a data capture application, or some client that is pushing data into the system. You want to just check it first. So if I filter by out of bounds, I should have nothing because I, moved all of my out of bounds data into the proper range. And now again, I can accept data points individually, or I can just accept the whole batch by clicking accept. And there we go. My data has been accepted into my plants data set. So I have some plant heights measured at the plant level. Now what I can do is I can calculate the average of the plants at the plot level. So for that, I'll go to execute actions, execute calculated variable. So the destination datasets is the plot observations dataset. So that's where I want the results of my calculation. The variable that I want to calculate is plant height measured in centimeters. I have only one instance, so nothing to choose there. And so now the system has found that plant height is in two places. It's in the plot data level and at the plant level. So I have to choose from where do I want to take the input for the calculation. And given that I've taken observations at the plant level, I want to use that. Click on calculate, and I get the average of my plant heights measured at the plant level in the plot level. And you can do this. I mean, I just did one instance, but you can do multiple instances at the same time. And that actually, this is just a function average, but you can combine it with other arithmetical operations. In terms of functions, we have average, sum, and difference between dates. Those are the three functions that we have implemented, and then all of the arithmetical operations. And all of those are configurable through the ontology. That's basically the demo. I mean, in the backend, the UI is the UI is exclusively talking to the backend through API. So all of the actions that I've taken via the screen, they can be done through APIs, which I think it's quite exciting. And speaking of my experience with the EIR, I mean, the University of Queensland, they already have taken advantage of the APIs that we've developed for this new observations module, and they already built a client that would pull data sets from the BMS and do some conversion into the data capture application that they are encouraging EIR to use, which is Field Scorers, an application that has been developed by them. But regardless of the tool of choice, I mean, to me, the important thing is that we've enabled this team to extend the capabilities of the BMS by building clients that act as that facilitates interoperability between the different tools that they are recommending. I've seen firsthand how undesirable file manipulation can be, and so I think I gained a renewed understanding of why is it so important that we do everything we can to make it seamless to the users, to move data from one place to the other with minimum user intervention. And I think it was a cool example of the kind of things that we want to enable with, moving our modules into an API-driven architecture. The APIs are now a usable product of the BMS. It's not only for the users to interact with the applications, but for clients to start consuming and extending whatever capability we can provide. And so when we did this following a couple of principles, I would say, as you see, so we try to keep, delivering while we were going through this transition. And we wanted to, we valued, iteration over just having a full-blown reengineering that would take 2 years. We valued, we consider that, even if we valued more the value that we were delivering to the customer, more than any potential bigger value that was still in development. See what I mean? So whatever we could deliver, we would deliver, even if it wasn't, the whole thing that we wanted to deliver. So that provided us with some opportunities to gain, early feedback, to test our assumptions, and to to avoid trying to analyze and design the whole range of changes in one shot. We were putting things to a test and getting the feedback and trying to adjust based on that. Whatever opportunity that we had to simplify, we took it. It's very, simplicity over complexity. It's especially with a tool like the BMS in our domain, like the one that we are in. Whatever opportunity that we have to simplify, we just have to take it because there are not that many, and so that's a guiding principle. And then direction over velocity. So if you look at it, it took us 1.5 years to deliver sub-observations. Well, a little bit less, because to be honest, we had sub-observations, functionality before version 13, but it took us a while. But I think that's, we value more, going into the right direction than just delivering with the maximum amount of velocity possible. We want to focus on doing it right, because we think that, we know that good architecture is expensive, but it's much cheaper than bad architecture in the long term. So we want to make sure that we do things properly and trying to build things in a way that is maintainable, scalable, and all of those things. And then my final slide is in terms of the next steps. And so we're going to try and do the same thing with germplasm management. Germplasm management is one of our oldest modules. And so we want to follow more or less the same principles which are outlined here: isolate, simplify, modernize, and optimize. I would say isolate and simplify there. You can first simplify and then isolate, or first isolate and then simplify. But we're basically going to take the same approach. So we currently, the germplasm management and the seed inventory management are tightly coupled and intertwined, and we want to decouple them so isolate the seed inventory management part of the germplasm management, simplify it as much as we can, then build a whole new API-driven architecture to manage inventory and optimize performance and so on. But that would basically make the germplasm management lighter in a sense for the for the re-engineering that we would have to do in that area. With that, I think I'm pretty much done. I don't know if Erik, you have some comments or final remarks that you want to make. I think we're very much on time, no?
Yes, you're doing very well with time.
Fantastic.
So any, go ahead.
Yeah, sorry, Mariano, this is Kelly. I just had a question. What do you really see as your top priorities in terms of next year, and where do you hope to be at in terms of deployment and adoption with a lot of the centers that you're working with?
And in terms of deployment, you mean, not necessarily development?
Well, kind of both. I guess I would let you sort of take that question in the direction that you feel comfortable with, but just in terms of where you see BMS being at the end of next year, both in terms of feature development as well as adoption.
I would hope that by the end of next year, we have an API-driven architecture for the germplasm management, meaning that we would, all of the front end is talking to the back end through APIs, and of course, I mean, to me, that's moving from an API-driven architecture. I mean, so exposing wrapping calls when you have an API-driven architecture is just a matter of styling in a sense. It's very, very easy. The problem is when you don't have that architecture and you have to kind of force the wrapping standard on your API set. But so my main goal would be to have the germplasm management function in an entirely API-driven way with all of the wrapping related goals in place. I know that's also the goal for the study management. We still have to implement the wrapping version of the goals that we've developed. And in terms of adoption, I mean, to me, the key is finding those opportunities to materialize, to make use of the architecture that we are forging ahead with. You know what I mean? So being able to interconnect with all the other tools that are working on interoperability. I mean, because if you have an extensive set of APIs, but no one is consuming them, that's kind of a sad story, right? So we want to expose more API, build our, change our architecture in an API-driven way, and work on concrete projects to materialize interoperability.
Good morning, everybody. This is Jean-Marcel here. Kelly, you wanted to have just some words on deployment and adoption by the end of next year. Did I get you right?
Yeah, I mean, it was a fairly open-ended question. I was just curious, but yeah, a little bit about you know, in terms of the centers you're deployed in, potential expansion, what your plans are for next year, and also any insights into how you're tracking use of the system.
So, I mean, just to say a few words, you know, on each of the three kind of pillar that we have for, you know, in the income strategy. Well, in terms of in Africa, for example, we continue to focus. We have probably now about 15 institutions that have adopted, or that where we have deployed the BMS over the last few years. We moved, you know, really from individual adoptions to institutional version. And over the next year or two, I do not see too many new institutions coming on board, perhaps 2 or 3 of them, but rather, again, focusing on adoption. So we continue to work with them to really have them using the BMS. At each of those institutions, we have currently champions, but, you know, in most of the cases, we cannot claim that there is a broad adoption per se. A number of institutions also use it as a repository. I think it's fair to say that most of those institutions, all the trials, nursery crosses are registered in the BMS, but, you know, the reality is that, or it's done by somebody after the fact, or there's a central person that prepare the field book and the crop cycle. But we are not at the stage where really, you know, a large number of breeders in those institutions are using the BMS themselves, you know, to design their program. This is where we want to be really. So already good step in terms of digitizing the breeding, but in terms of adoption, we are still going to work heavily on this over the next 1 or 2 years. On another side, you know, is continuing to play a role to provide support. We continue to look for interaction in new projects, to be engaged also in new initiatives. And again, as you know, we are positioning ourselves really also in the landscape for institutions that might have more than one crop information system. So again, this is a responsibility that we are taking on, and also that perhaps, you know, at some institution will even be engaged in the migration of some from one system to another, where when there will be a demand. And the last perhaps components, I mean, we continue to have an increasing adoption by some paying users outside developing countries. It's slow, but it's continued to come on board. And again, these, you know, contribute also with this to our income strategy, to try to at least have some sustainability over time. And again, this is taking place. We especially have quite some adoption now in Australia and in Europe. So it's going on. So this is in a nutshell where we are going. And again, I think the major opportunities for new activities will be in the second area in terms of support services, interacting with new project and initiative, and again, being on the ground to support. As you know, I mean, deployment is easy. You know, this is really the true adoption, and not only of the BMS, but perhaps also at a number of other things like, you know, harvesting samples for DNA, and you know, also data capture and other things. And by the way, I mean, in Accra now in Ghana, they will have in a couple of days the first meeting of the African Breeding Association that has been formed early this year. And as you know, there is quite a number of opportunities here to participate to different initiatives.
Thank you very much, Kylie, for the question. Also, Jean-Marcel, for the overview on the deployment adoption strategies. Anyone else on the line have questions? We still have another 15 minutes.
If no one else has a question, I have another one.
Hey, can you hear me?
Yes.
Sorry, I had a little trouble with my headset. I wanted to comment a little bit more on adoption, and first of all, as Jean-Marcel said, it has been an eye-opening experience, just the chasm that exists between deployment and adoption, and what a whole large challenge it is to get from really just the institution coming to the point where the leadership accepts or decides to deploy, to the point where the breeding teams are really adopting that. And I had a little experience with that in a commercial setting with seeing where there could be resistance to adoption and the different components of a strategy to really get adoption. And clearly, part of it is providing the right technology and the right technology package, so that you had the supporting elements, the printers and handhelds and so forth that are needed for the system to work effectively. But then there also needed to be a mandate. There needed to be a credible decision with consequences that the organization would make the change, because change is always difficult, and changing your breeding practices is difficult, and there will be problems in adopting a new system where you find yourself under tight deadlines and struggling to make the pieces work the way that they used to work. And so it's never going to be without pain. And at some point, there really has to be a decision to make that change, and then both carrots and sticks to make that happen. And what I have observed is that we have problems at a number of different levels. We have challenges with just the technologies that in different countries we have different printers and different handhelds and different systems that make it difficult for everything to really work smoothly together. And we have different levels of resistance to change, and then different levels of commitment on the part of the leadership to really wield a stick and say, these changes are necessary. And so that, I think, as the EiB looks at really trying to drive this bigger picture forward, it's going to be faced with those challenges as well. And I think that part of the equation is going to have to be some agreements with measures of what the consequences are going to be to help drive the process, as well as a lot of focus on making sure that the enabling technologies are in place to have a complete system that really works at all of the different interfaces that a plant breeding program has. As far as adoption, what we have done is whenever we deploy the BMS at an institution, we have an agreement that's signed by both parties. So we have an agreement that specifies the deployment, the service level that we're going to provide, the help with data migration, the assistance with troubleshooting problems that we're going to provide, and we offer to monitor the usage of the system, so that each time we upgrade, which is done on a trimester basis, so every 3 times a year, we are committed to delivering a new version. And when we upgrade the system at the institution, we can analyze the data in the database and determine what activities have been taking place, how many new germplasm lines have been created, how many new studies have been created, how many nurseries, how many crosses. So we can gather a lot of information about how the system is being used. We can, to some extent, correlate that with different users. So there's different levels of statistics that we can provide that will give a lot of insight into the adoption. And we've seen this in institutions where they're deploying the system in multiple crops, where for some crops we'll see a lot of activities, new germplasm being created, studies and nurseries being generated in one crop, and then another crop, really very little activity. And it's clear as day, which of the breeding groups have been working on adopting and implementing the system as an integral part of their breeding program, and those programs that have not. And there's opportunities to extend that as a measure of adoption. Abhishek at ICRISAT has developed a nice dashboard that the management at ICRISAT can use to look at activity for the different programs. There was interest from the African Research Council on using a Microsoft tool, and I forget the name of it right now, but it's a SQL query-based tool that can provide dashboard graphics to indicate, to summarize data from a database, and there was interest in using that to help monitor activity within the database. So that's really, at this point, the best indicator that we have for adoption, besides just the engagement that we have with the users, the feedback that they give us, the questions that they raise. I mean, it's, we can see who is really active in what institutions. But I think going back to this agreement that we have, that this is something that the EIB should be thinking about as well in their partnership agreement with the partner breeding programs, is to encourage the partners to be willing to have this kind of data analysis on a regular basis that would really give them insight into the level of adoption, where it's getting used, where it's not getting used. You can see that the breeding program has started to use the system for running trials, but they're still making their crosses outside of the system, and so that's the next place to focus the effort in bringing the breeding program on board. So that's a little bit of comments about adoption, and I will say that it's been eye-opening and in some ways discouraging to see the steep hill that has to be climbed to get from having a tool that really is useful, never perfect, but a useful tool, deployed at an institution, and still struggling with getting the breeding teams to really adopt it. And that's going to continue to be a challenge in the geographies that we're working in. Finally, I wanted to just elaborate a little bit on Mariano's comments about where we want to go in a year. We're focusing on the germplasm module. There's two, besides wanting to get this core module into an API-driven mode, we're also motivated by the request from our users to implement some new features in the inventory module. And so by going through down this path, we expect to be able to add new features of interest that have been requested by our users in supporting inventory management. And also a key thing is that we have, as Mariano mentioned, this is the oldest module, and we have the user interface library that was used for that module is now antiquated and no longer supported. And so it's becoming more and more urgent that we replace that library with a current library, so that we'll be able to continue to maintain effectively the tool. As the library becomes, the longer the library is out of support, the more difficult and expensive it becomes to maintain and fix bugs in that part of the system. So that's another driver for that. Also, we continue to work with the Gobi team, and so we really hope now that the with the progress being made on the Gobi side with some of the APIs that we need for exchanging data with Gobi, that we can continue and pursue that strategy of focusing on the core areas and then relying on interfaces with other systems to provide more the remaining functionality that any breeding program needs to be a fully modern breeding program. So I rambled too much, but so I'll stop there.
Thank you very much, Erik, for the more complete picture on both deployment and also some additional maintenance or the feature development. Anyone else on the line before we ask questions from the Gobi room?
I just want to follow up on Erik's comments and everyone else's comments too. Adoption is really difficult to have some tracking. We have tracking metrics too, and they certainly help, but I think that's really important discussion for next week in Summit, is how we improve adoption, both in terms of tracking metrics and encouraging people to use the system. And yeah, we're very excited about the APIs that we're developing now, especially with Bracky 2.0. I think that's really going to make a huge difference to how we can integrate together.
Thank you, Liz. Anyone else on the line have questions? Okay, so okay. Thanks, Kylie and everyone. I know time's up. I can follow up separately with Mariano and Erik. My key question is how the data architect you showed, Mariano, different from what the EBS architect, and also the current API strategies in terms of in-system modules and also outside the systems across projects like Gobi or BMS, the API strategies. So 1 minute quickly, Erik or Mariano, you want to comment on that, or we can just follow up offline?
I'm not sure I understood the question.
The first question is the data architect picture you showed at the very beginning, how that is different from the EBS data architect. The second one is the API strategy in systems, different modules versus across different systems integration.
So I got the first question, which is, I think you're referring to this diagram here, and it's the same diagram that has been presented by EBS. I'm just outlining the areas where we would like the BMS to play a role in, and the areas where I don't think the BMS has. I think where we think the BMS has to leverage other solutions and not try to fill that role. It's the same diagram. I'm just overlapping the areas of interest of the areas of influence, if I may, in terms of where the BMS could fit within this architecture. And the second one, there's some noise on the line. I couldn't quite hear the question.
Yeah.
I don't know if Erik, you got it or not. I couldn't.
Second question is the current different modular, you isolated different modular within the systems, how you integrate in order to work well versus the integration strategies with Gobi or outside of the systems, the tool integration. The
strategy is the same, I think. There's there's some difference in the level of emphasis on public APIs, on BRAPI type APIs, but I think the strategy is really quite basically the same. And so as Liz pointed out, with Gobi, our focus is on using the BRAPI standard APIs to be able to interface with Gobi. And so I think that the strategy is fairly similar. I mean, EBS has a more, I think, ambitious vision for how they are going to manage services and APIs, and we're still learning about how that's going to be opened externally, and what the final picture is going to be. But I think that to a large extent the strategy is the same, but from my understanding, EPS is going to have a more sophisticated model for how they can manage and interface and schedule services in a larger network of services.
Sure. Thank you very much, young Erik. Yeah, so the time's up. Really appreciate Mariano, John Marcel, and young Erik for the overview, the demo, and it's great to see the new API-based development, and also excellent to see the data capture and then the QC and how that's set up in your current study. And then it's great to see your deployment and the adoption strategy. We definitely learn a lot. I think across system, cross project, continue working towards the integration and learn from each other on how to best solve the challenges in the integration at the institution level, at the management level, also the truly lead by. So with that, for everyone on the line, also in the room, thank you so much, and have a wonderful day. And we'll see some of you next week at the CIMID during the Module 5 planning meeting. Bye now.
Bye, Star. Thank you.
Bye. Thank you for the space again. Bye-bye.
Yes, thank you.
Good night, everybody.